Come with me. It is the only way.
No. No. What? No. I don't care if you're in here. You're dead. This kid is dead because, physics. I'm gonna figure out exactly how dead he should be, but I'm gonna need some help.
Help me, Obi-Wan Kenobi. You're my only hope.
Actually, I'm not looking for Obi-Wan. I'm trying to find...
Are you there, sir?
Hey, 3PO. Awesome.
Hello. I am C-3PO, Human Cyborg Relations.
Yeah, I know that. Just a sec. Awesome. Hey, I need your help.
I'm going to regret this.
Yes, you will. So there's a scene here, and I've got to figure out how dead Luke would be. But, there's a lot of physics. I thought maybe you guys can help. So, there's 3 parts to this. The fall, the slide, and the antenna. The fall is the easiest part. R2, what's the formula to figure out the impact he feels when he hits the vent? Force equals mass times acceleration. And how do we figure out acceleration? Okay, acceleration equals change in velocity over change in time. How do we figure out velocity? Velocity equals gravity times time. Okay, that I can do. The gravity constant is 9.8, and if we watch how long he falls, it looks like...
Are you sure this thing is safe?
No.
They're dying, R2.
Not yet. His fall lasts... 11 seconds, holy shit!
You watch your language.
Sorry. RJ, what do we get if we multiply 9.8 times 11? 107.8 meters per second. BB-8, what are you doing here? Oh, terminal velocity is a thing? Hey, were you two gonna let me do this whole thing with the wrong numbers?
But don't blame me. I'm an interpreter. I'm not supposed to know a brass socket from a computer terminal.
Hey, be nice. BB-8 says that Luke would peak at 54 meters per second, which is the terminal velocity for a falling human. So he goes from 0 to 54 in 11 seconds. What's the acceleration? The acceleration is when he stops? Ugh, this is complicated.
I've got to rest before I fall apart.
Same.
I don't think I can make it.
Okay, acceleration when he stops. Usually that would be 54 to 0, but he doesn't actually stop. We have to go a bit into the second part. Look at this. I have no idea what the heck kind of shape this water slide funtime air vent is supposed to be, but he passes about 5 sections of these in 1.5 seconds, and he's about as tall as 1 section. I don't know, do that math for me. 5 seconds at 1.75 meters each because I stalked Mark Hamill on Wikipedia and I know his height. That equals 8.75 meters in 1.5 seconds, or 5.8 meters per second. That's 54 to 5.8 meters per second in, let's be generous and say 0.3 seconds. Oh, okay, so that's an acceleration of 160 meters per second. Okay, multiply that by his mass, which is 73 kilograms, because I also stalked the Star Wars Wikipedia page, and you get 73 times 160 equals 11,723.8 newtons. Dead. Dead. Luke Skywalker's dead. Wait, that's the net force? I have to add his weight in newtons? Multiply 73 by the gravity constant, 9.8. You get 715, and you add that, and you get, what? 12,438.8 newtons that he feels. Oh, so he's more dead. On to part 2.
Congratulations, you are being rescued. I'm K2SO. I'm a reprogrammed Imperial droid.
That isn't very reassuring.
Okay, I thought I told you not to come.
You did, but I thought it was boring, and you were in trouble.
Fine. Help us out. Just for context, do you happen to know how high that fall that Luke just took was?
It's high.
Incredibly helpful, as always. So while he's enjoying dear old Dad's super Sithly wet and wild fun time in the galaxy's #1 weird-shaped air vent, he goes from 5.8 meters per second to 0 in what looks like 7 seconds? His acceleration is 0.82 meters per second. Oh good, something that won't kill him. And his net force is 59.86 newtons. plus his weight is a total force of 774.06 Newton. But aren't these forces in kind of different directions? His weight goes this way. He's moving this way. Do any of you guys know what to do with that? I'm just gonna ignore that.
I haven't completed my calculations.
Too bad. Moving on. This is the most realistic part of the whole thing. Given the fact that they can't exactly shoot Mark Hamill into a tube at terminal velocity.
But that just wouldn't be proper.
Doesn't sound so bad to me.
How rude!
Are you talking about me?
I've just about had enough of you.
Quiet!
Shut up. He's totally stopped here, and then he falls. Again, there's some vent slide fun time, but I'm gonna ignore that again, and say his initial velocity when he exits the tube is 0, and the time it takes to when he lands on the antenna is 1 second. So his final velocity as he lands is 9.8 times 1 equals 9.8. Let's say he stops again in about 0.3 seconds, so that's an acceleration of 32.6 meters per second squared, and multiplied by his mass is 2,379.8 newtons of net force that he feels, 3,094.8 newtons of total force that he feels. Yeah, he's dead. Okay, maybe not dead from the impact here, but might I remind you that he just got his arm cut off, and he's just been informed that his father, who he previously thought was dead, is actually the evil guy in charge of the galaxy, who just so happens to be the one who recently just cut off said arm. He's not doing well. Falling out of a hole and catching yourself with the back of your knees?
That is a bad idea. I think so.
It is a bad idea. Do you know what would probably happen to even a completely healthy human? He'd destroy his knees, slip off the bar, and fall backwards into the void of space, or whatever's down there. If most of us tried that, we'd be dead.
Not me. I can survive in space.
I'm aware of that, Kay. I said humans. You're not human. Anyway, I think we figured it out. Thanks, guys.
You're right. I should just wait on the ship.
No need for your sarcasm. You weren't even that helpful anyway. But thanks for the moral support.
Cassian said I had to.
Apparently Cassian wasn't very specific on the definition of helping.
Now don't you forget this. Why I should stick my neck out for you is quite beyond my capacity. No more adventures.
Sure, but only for physics.